Number 1 says evaluate the following numerical expressions. Evaluate means to find the answer. If I have 2 and -3, that makes -1. -1 plus 7 is a positive 6. We can leave and then change that to a -1. So -4 plus -1 makes -5. In this one, there is an invisible 1 under the 2. -5 times 2 is -10, and 2 times 1 is 2. -10 divided by 2 is -5. In this one, we need to use order of operations. Division comes before addition. So -10 divided by 2 is -5. And then we add 3. That tells us to go back towards the right. So our final answer is -2. E, we have half times 8 plus 2. The order of operations tell us to do multiplication before addition. Half of 8 is 4, and 4 plus 2 is 6. F, we have 3 plus -4 minus 1. We can change this piece. So we have -4 and -1 make -5, and 3 plus -5 is -2. Number 2 asks which expressions are equal. So A and E are equal because those are both 6. B and C are both -5, and D and E are both -2. So those are the sets of equivalent expressions. Number 3 asks us if 2 of the equivalent expressions from exercise 1 are divided by 3, write an if-then statement using the properties of equality. So if, in problem 2, we said that D and F are equivalent to each other. So if -10 divided by 2 plus 3 is equal to 3 plus -4 minus 1, then -10 divided by 2 plus 3 divided by 3 must be equal to 3 plus -4 minus 1 divided by 3. In class, we talked about how if they start out equal and we change them both the same way, and in this case being divided by 3, then they will have a result that is equal to each other also. Number 4 says, write an if-then statement if -3 is multiplied by the following expression. So if -1 minus 3 is equal to -4, then if I multiply -1 minus 3 by a -3, it will be equal to the other side, which was a -4, also multiplied by -3. I'm going to do those two in a different color so you can see the start and the end result. So if they start out with these pieces, then when we multiply by -3, both of those pieces are still equal to each other.